Daniel Bonnet, a physics professor at the University of Amsterdam and the paper's lead author, says that after discovering the painting, he and his team conducted a laboratory experiment in which they built a smaller version of the Egyptian sled in a tray of sand, with the weights ranging from 100 grams to a few kilograms. When the sand dried, a sand heap formed in front of the sled, impeding its movement. The sled required a relatively high force to reach a steady state. Adding water stiffened the sand, and the heaps shrank in size until no heap formed in front of the moving sled, and thus a lower applied force was required to reach a steady state. The trick is to use the least amount of water possible. The sled's movement would be hampered if the sand was too dry or too wet, according to Dr. Bonn. Dry sand, as we all know, does not make good sandcastles. However, adding water changes the equation and solves the problem. When there is enough water, these bridges act like glue, holding the grains together. This is great for sandcastle construction and, as it turns out, sand transportation. Less force on wet sand means that the number of men needed to pull the stones could be cut in half, according to Bonn.